Hello, welcome to another episode of GenServer. In the previous episode, we defined our server module, which is the message server, and it's responsible for handling sending of messages to different phone numbers. In the server module, we also defined the init callback, which will handle the initialization of the GenServer process. The init callback takes in one argument, so this argument can be passed during the runtime when starting the GenServer. Inside the init, a simple task was performed. So the init callback performs a very simple task. So it prints the argument received and also defines the initial state. So the initial state here is a map containing the max retries. So it's a map containing the max retries and the phone numbers. So the max retries here will be retrieved from the initial argument, and if it's not passed, it defaults to 5. And the phone number initial state is an empty list, so this is a placeholder of the phone numbers whose message will be sent successfully. Then we print the initial state and finally return a tuple of an atom OK and a state. So this signifies that the GenServer process will be initialized successfully. Let's start the GenServer process. So go to the IX by running the command ix-s mix. So to start the GenServer process, let's call the GenServer .start. Facet the message server module, and then the initial argument, which is a keyword list in our case. So I'm working with the keyword list because that is what is expected within our logic, but you can pass any data structure that you want. Can be a string, can be a map, whatever you feel comfortable working with. So I'll pass a different values, 3. So when I run that, you can see that we have the printed message, which is the argument and the initial state. And also we have the final output as a tuple of an atom OK and a PID. So this shows that our GenServer process has been started successfully. So then the initialization of the GenServer process here has been rather fast, and this is because we are performing a very simple task within the init callback function. Now imagine you want to populate the state with the data retrieved from a third-party API or a database. So that logic can be a bit complex because let's say we want to retrieve from the database and this information is too large. It means that it will be time consuming waiting for all that information to be retrieved, then passed to our state. So performing that logic within the init callback can be complex, and it might delay the initialization of the GenServer process. So now, if you want to perform such a complex logic, I would recommend not performing it in the init callback. And in today's video, we shall learn how we can avoid delaying the initialization of the GenServer process while working with the GenServer. So let's get started. So first, let's demonstrate the complexity and how our server module will behave if we perform that complex task within the init callback. So to do that, I'll just do process.sleep. And sleep for around 30 seconds. So let's assume that retrieving a large information from within the database takes around 30 seconds. So recompile, then start the GenServer. Let's start the GenServer again. So you can see, so this is how we have to wait for the initialization, for the GenServer to be initialized or started. So I'm waiting for around 30 seconds. So in this example, you could see that we had to wait for the delay for the 30 seconds to elapse, then for the 30 seconds to elapse for our GenServer to be started. So this clearly states that the init, we are working with a synchronous function, and init function is a synchronous function, and it means if it's performing a task, the execution of the task should be completed for the GenServer process to be initialized. Workaround in this is to post initialization work. So what do I mean by that? So instead of us performing a complex logic within the init callback, we shall let the init callback initialize the GenServer process as it should be, then perform. So once the GenServer process has been started, we shall perform the task that we meant to do in the init callback to we shall perform that task that was supposed to be done in the init callback in another callback function, then populate the state from that callback function. So to do that, first let's comment this out. So we are not performing a complex work within here, so I'm commenting this out. And then after that, let's, instead of us returning a tuple of an atom OK and state, which we shall return another return value, which is provided by the init callback function. So let's go to the GenServer doc. If we go to the init callback, you could see that we have like 4 different return values. So we have this is what we have been working with. So now we want to work with this. So in our case, we shall return a tuple of an atom OK state, then pass a tuple of an atom continue and the instruction we want to execute. So in this case, let's assume we're working with a database. So let's say fetch from database. So this return value is similar to what we had at first, but it's similar to what we had at first. So it will start the GenServer process successfully. However, with the addition of the atom of the tuple of an atom continue and the instruction we want to execute, it will help us to perform a post initialization work. So this way, we shall avoid blocking the server from starting. So let's see how this works. I will recompile, then start our GenServer process again. Okay, so one step at a time. So in here, you could see that our server was initialized, but then it got to be terminated. And it got to be terminated because of an error which has been raised. So we have undefined function error, and it states that the handle continue of RT2 is undefined or private. So let's see what is here. So we have also been passed the handle continue. So we are supposed to define a handle continue function and pass it the first argument fetched from database, and the second arguments look similar to what we have in the initial state. So let's see how the handle continue works first. So in here, we are told that the handle continue takes two arguments. So the first one is the continue argument, and the second one is the state. So if we go back to our error, you can see that the first fetch from database, it's the continue instruction we passed in the init callback. And the second argument is the state, which is matching the initial state that we passed. Okay, so now that we know how to handle this, let's define the handle continue callback function. So we have the handle continue. And in the handle continue, we know that we need to pass our continue instruction because that is what it's expecting. And the second argument is the state. Let's pass it as the state as it is. Okay, so what we're now forgetting is what is the return value supported by the handle continue? So if you go here, we can see it also has different return value. So the first one is a tuple of an atom, no reply, and a new state. So this one can be used to update the state to a new one. Then the second one, we have a tuple which contains an atom of no reply, the new state. We can return a timeout or an atom hibernate, or also return a tuple of an atom continue and a continue argument. So this only means, so if we return the first return value, we can have the opportunity to update our state. And with that, we can take advantage of it. So for the second one, if we do no reply new state and return a tuple of an atom continue and a continue argument, it can be useful when we want to perform, when we want to split the work in multiple steps. But let's go with the first option. So I'm going with the first option because remember that we wanted to perform a complex logic within the init, but we saw the disadvantage of that. And now we're doing a post-initialization work. So instead of us updating the state within the init callback, we want to update the state within the handle continue callback. So the first return value will do justice for us. So we shall return no reply and the state. Okay, so here is where we are performing a complex logic. So I had already defined it. That's why I want to just copy this here. So let's sleep, assuming that we're retrieving information from the database. And once we retrieve that information, let's populate. So the best way to do this is let's define our users. Just to make it real for a bit, to make it real at least. So I'll quickly do this, define our users. So we want to have 100 users. We're assuming that we are having 100 users retrieved from the database. Then with that, I'll just define a map. So I'm quickly doing this. So we have the user ID. as the number. Then we have the username. So to have the user, let's have, so that will be user. Sorry. So let's pass the number here, and outside here we pass the user. So that was the information that we'll have from the user. So here we are iterating through a range of numbers, that is 1 to 100. And for each number, we are creating a user with the ID matching the number and the username. And the username where we have interpolated a string user and the number. Okay, so now that we have that, so it takes like 30 seconds for us to retrieve that information. So we have a list of users, and this users is what we want to update our state with. So to modify this again, let's update our state. No, I remember we can't. So let's use the map.put. So we have the state. Then we want to introduce another key, which is user and users, because there are many. Then pass it users. Okay, so we have performed. Okay, so with this, we've been able to perform a post-initialization work. So let's recompile and then run, and then start our GenServer, another GenServer. Okay, so we have an error, and where has this come from? Let's do that. Let's recompile. Okay, so what happens if we start the GenServer? So once we have started the GenServer process, you could notice that the initialization of the GenServer process has been very fast compared to how it was before, when we decided to introduce some complexity within the init callback function. So that's it for this episode. In this episode, we have seen how you can avoid delaying the initialization of the GenServer process by returning a tuple of an atom, okay, the state, and a tuple of an atom continue term, which is another return value for the init callback function. So this return value is great for doing post-initialization work. So that said, instead of performing complex tasks when initializing the process in order to populate the state, consider performing a post-initialization work. So that's the beauty of the GenServer.